Welcome everybody. So today a webinar about, as Kerry says, bias due to missing data in the ROB2 tool. Here's an outline of what we're going to do. We'll start with an introduction to what missing data are and talk about some of the theoretical ideas around when they will lead to bias in an estimate of an intervention effect. We'll stop briefly after that before Jonathan starts talking about, in a more practical sense, how we know about whether there's likely to be bias and some issues around some methods to try and address missing data, and to say a bit about time to event analysis. And then another brief pause, and then we'll run through exactly how we've operationalized all of this in the risk of bias ROB2 domain. And there'll be hopefully some time for more discussion at the end of the session. Before we start, as usual, we just remind you of the sources of bias in a randomized trial to put the session into context. We start with, in the ROB2 tool at least, by thinking about bias arising from the randomization process. Then we look at whether the interventions were delivered as intended or whether there were deviations from those intended interventions. We'd like to follow everybody up, but sometimes don't. We have missing outcome data. And then when we do get to the outcome assessment, we worry about whether there's bias in its measurement. And then in the reporting of the trial, we worry about bias in selection of the reported result. So today's session was about the third of these 5 domains, bias due to missing outcome data. I just want to stop by throwing it out to you, just to give me some sort of the sorts of situations or reasons why we might have a missing outcome data in a randomized trial. So I invite you just to throw any thoughts you have into the questions box, and we'll look at them, and I'll read some out and see whether we have a good sense for when we're going to have missing data about outcomes in a trial. So we're having things like loss to follow-up, dropouts. Any other thoughts? Participants moving out of the area so they no longer attend the clinic. Deaths, good one. Not reported. Ineffective treatment, relocation, bad response to intervention, serious adverse effects. Okay, lots of great thoughts here. Thank you very much. Well, trialists decide to exclude certain participants. Not answering questions, non-participation in the intervention, or a protocol deviation. Right, there's an interesting mix there. Okay, let's stop that now, and we'll get back to the slides. And I'll show you the ideas that we had written down, which are essentially all the ones that you said. So participants may withdraw from the study, or we can't locate them to bring them back. They might attend for a study visit, or they might not attend for a particular visit at which an outcome is going to be measured, even though they haven't completely dropped out of the trial. Or they might turn up for a visit, but for whatever reason not provide outcome data. Or even if they provide all the data, those data may get lost. The records may get lost, or for whatever reason be unavailable. Or, as someone pointed out, if someone dies, or as certain other types of event, it's no longer possible to experience perhaps the outcome of interest. I want to use this opportunity to draw a distinction between missing data, which are data we'd like to have but don't, versus exclusions from analysis, which are when we do have data, but those data are not included in the analysis. That's normally the trialist's decision rather than ours. But even so, we make a distinction between these two, because exclusions of data held for reasons of analysis, they're all covered in domain 2 that we talked about last month. That's around deviations from intended intervention, where we talk about the extent to which, if we're interested in the effect of assignment to intervention, whether we've done the full intention to treat approach has been taken, which does require all the people to be in the analysis. So exclusions are in domain 2. Genuine, truly missing data that we just don't have, or the trialists just don't have, are in this domain. So it's not going to be stop, start right through. But I want to do a poll now just to get your view on this question: how much data is too much outcome data being missing? So, Dara, if you just open the first poll, got a few options, and just see whether people have thoughts on. Just opening on my screen. So I've got options of 5%, 10%, 20%. I've got quite a lot. It's quite a close race between 10% and 20% at the moment. I've got 75% voted going up. Let's see if we get over 80%, then that's at least I've got less than 20% missing data. Of course, your own answers may invalidate the poll if you're right about answers. Okay, let's stop. And let's have a look at the results. I don't see them on my screen. Why is that?
I can read them out.
I can read them out. I can see them on. I can see the numbers. So we have 11% on 5 at the lowest threshold of 5%. 37% of you said 10%, and 42% of you said 20%. 10% of you abstained. I think the best of those 4 answers is the last one, abstain. There really is not, in our opinion, a sensible threshold that we can routinely apply for small enough in relation to the proportion of missing outcome data in a randomized trial. Although it is true that if missing outcome data are leading to bias, then the more data that are missing, the more bias there will be. But that is there's a continuum, and to draw a threshold along that is not helpful because it's not the only consideration in terms of the extent or the risk of bias due to missing data. Yes, the number of participants with missing data is important, but so are other things. Issues are different for different types of outcomes. For example, continuous outcomes are usually more robust to missing data than dichotomous outcomes can be. When we're looking at dichotomous outcomes, the risk of the event is really very important in the potential impact of missing data. So even 5% missing data for a rare event could have a dramatic impact on the effect of the intervention as estimated by the trial. So the question is, well, how do we think about when missing outcome data lead to bias? And the next few slides I'm going to present are from a kind of a theoretical perspective. You might think, oh, but I can't know that. But let's talk about what the situations in which bias really will arise from a theoretical perspective, and then Jonathan will start thinking about some of the more practical ways in which we can try and diagnose some of these situations. So the key thing we need to think about when thinking about missing data is whether is about, well, what was the true value that we would like to have seen but is missing from those participants. So it's the true value of the outcome in participants with missing outcome data. So if we think, for example, of a trial of CBT against usual care in people who are suffering from depression, some people who are more depressed may be less likely to return for follow-up. And if that's the case, then clearly the missingness, whether people are missing, is more likely with more depression. So it is related to the true value of the outcome. This means that those that we do observe will have systematically different depression outcomes from those that we don't observe. And that's the situation in which biases are likely to arise due to missing data. So you'll see that a lot of our thinking around the tool is relating things to the true value of the outcomes among those who were missing. So I've got a few diagrams to illustrate some situations in which there won't, or may not be bias. But here's a depiction of some outcome data in a randomized trial comparing an experimental intervention versus a comparator intervention. What I've drawn here is a kind of a histogram of the observed outcomes for those in which we have the measurements. And so we've got pink for the experimental and blue for the comparator. But in each of these arms, I'm saying there are some missing participants. And the question is, well, what are the values of those outcomes had they been measured in those who are missing? And for the sake of thinking more concretely, we could imagine this is something like a mini-mental state exam measuring cognition used in dementia research, so where higher values represent greater cognition and lower values poorer cognition, i.e. symptoms potentially of dementia. So, so here's a depiction where we've got observed data suggest that there's higher cognition in the experimental intervention, the comparator, so maybe it's a signal that it's an effective intervention, but we're missing some outcomes. I've already used this term. Let me just say something about this word, missingness. Of course, the English language is very, very rich, and it's got a huge vocabulary, but it's missing one important word. And so we make one up for the purposes of missing data. That's used quite a lot in literature, because it doesn't make any sense to say presence of missing data. Obviously, by definition, it's not present. So there's not a word that describes the situation in which we have missing data, and we use the word missingness to depict that. That will be acceptable to everybody. Okay, so let me first show you a scenario where there is no bias. And that's a scenario that you probably could predict, where the sort of outcomes in those who are missing are just the same as the sort of outcomes in those that are observed. The missingness is unrelated to the true value. It doesn't matter what your level of cognition, you're just as likely to be missing from the study. So, for example, if the missing data are through just a technical error, so for example, an automatic measuring device fails for a certain subset of participants across the whole trial, then that's not going to be related to the symptoms of the participants. And so we would expect that we'd be in this situation where here, this would be evidence that the intervention is effective, because on average, cognition is higher in the pinks than in the blues. And it doesn't matter whether you're missing or not in terms of it doesn't depend on your cognition. But here's an example where there is bias. Now, there are two things going on here that differ from the previous slide. The first is that you see the distribution of outcomes that are missing is different from the distribution of outcomes that are observed. The lower pink histogram is shifted to the left. So that's saying that the people with more dementia are more likely to be missing. And the same occurs for the comparator intervention. But there's a second important difference here in that the number of people missing from the experimental intervention is rather larger than the number missing from the comparator intervention. And what we can say quite confidently is, if these two things hold, i.e. missingness depends on the true values and missingness depends on the intervention group, then our result will be biased. And so as an example of this, we may have missingness depending on a intervention group, because if it's a drug, we might get side effects and people might leave the study if they experience side effects. If we combine that with the general tendency for people with more dementia to be more likely to drop out, then this is the picture we would see, and we would have a biased estimate if we used only the observed participants compared with if we had everybody's outcome measured. Here's a third example. Here's a situation where, in fact, there is no bias, but it doesn't look like the first picture. Here, again, the observed data are identical, but here, the missing data do depend on the true value, because those with less cognition shifted to the left, they're less likely to be observed, but everything is identical in the two groups. The same pattern is happening of those with continuing symptoms being more likely to drop out, because the intervention has no effect. So I hope you can see that those two pictures are identical. It doesn't matter whether we observe or do not observe the missing people, we will still estimate the difference in those two means to be zero, because the intervention has no effect. We've got the same proportion and the same types of people missing from the two groups. On the other hand, and this is my final of these examples, supposing the intervention does have an effect, so I'm going to shift these a little bit so that now across all the pinks, the average is higher than across all the blues. Now, even though there's the same proportion of people missing data, and missingness depends on the true value, now the intervention has an effect, and this is a situation where we are likely to have bias. So what you can see from this, I don't know if you've followed all of that, is that it's not a very straightforward set of theory. And as you can see in the bottom lines in the plots, there is even more complexity to that we're trying to articulate in the guidance document. It's not an easy area, but we have, we think, come up with a tool that is reasonably straightforward to use, that encompasses nearly all of these ideas. So let's just have one poll, but I need to read a scenario first, and then we'll break for some any quick questions, but we won't spend long on them. So here's a scenario where we've got a trial of some type of physiotherapy versus no physiotherapy for people with some shoulder pain. And we were after a measurement of a subjective measure of pain in the shoulder. Now, suppose in the control group, we lose 15% of people who just, as is often the case, lose interest in the trial and stop coming back. But in the experimental group, the physiotherapy group, a higher proportion than 29% don't return. And the reason why they don't come back is because the early sessions of physio resolved their pain. And they thought, oh, well, that's fine, I'll just go back to my daily life and forget about the trial. So the poll now is to ask you whether bias is very likely, likely, possible, or unlikely. Okay, that's good. So we've got a very small proportion. That's 75%. Let's close at that point. So we've got a very small proportion saying unlikely. The majority view, 41% saying very likely, and then 31 likely and 26 possible. So I would tend to, I think I agree. I think this fills a situation in which there will be bias. We can't say how big it will be, but it looks very likely that there will be some bias because of these. The outcome, missingness is depending on the outcome very directly in the video group, and it depends on the intervention group because those proportions are distinctly different, although I didn't say how big the trial it was. But there's still quite sizable differences. Great, okay, let's have a short break. Not so much a break as an opportunity for questions around that, noting that there's still more to come, and hopefully we'll leave some time for proper discussion at the end of everything.
So Julian, Jorge Teixeira has asked, the graph with observed participants on its own is able to provide us with a part of that answer or not at all? And I think that's where we'll be coming. It's a really good question, and that's where we'll be coming to. The unfortunate thing is, so the graphs are useful to depict circumstances in which there will and will not be bias, or bias is more or less likely. But unfortunately, we can never plot those graphs in real life because we never see the missing values. So what we're going to come on to talking about is how to assess bias, because we will not know the missing values. We just have to think about whether there's indirect evidence that missingness in the outcome is related to the true value that we did not measure, so cannot see. So that's why this is a very difficult area. Should you look at the results when determining whether the bias is likely? Well, there is, if the effect of the intervention is null, then bias is less likely. But the problem is that bias could have made the effect of the intervention null based on the measured values, even if it's non-null based on all the values. So primarily, you should think about reasons for missing outcome data and indirect evidence leading you to think that there's bias, and we'll say a bit more about that later. I don't know if you want to do any of these, Julian.
A lot of these are things that some will become clear with the rest of the presentation, and others will be better discussed later. So I don't see any that stem. Well, ones that are the last of examples where the distribution missing data are identical between them. So in the last of the examples, yeah, I addressed that one. The point was that the I'll just put it back. The intervention had an effect. So if you, well, the way I've drawn it, the missing people had the same distributions, but the observed people had different ones, which means that if you add all the pink ones together and you add all the blue ones together, then you get something different from if you just compare the observed pink with the observed blue. So that means that
I think that potentially that graph could be improved a bit, Julian. The point is, if missingness depends on the true values, then the relationship between observed and missing in the experimental intervention will differ from the relationship between observed and missing in the comparator intervention. And it's not very clear from the graph. We can maybe improve that a bit. But that's the reason that if there is an effective intervention, then and missingness, it depends on true values, then we will get bias. The bias judgments we're going to come to. I'm just looking at some of the other questions. Does it matter if the characteristics of missing and non-missing participants differ? I think we'll say a bit more about sort of indirect evidence that missingness depended on the true values, but there isn't a simple answer to that question, Joanne.
Perhaps take Trevor's and then move on.
But maybe I could do Belinda's as well. So would it class as bias if the study was investigating effect of a certain treatment and patients died during the condition being investigated? I'd refer you to the guidance a bit on that one, Belinda, but a short answer is that if a patient has died, and so, for example, we can't measure quality of life, quality of life isn't exactly missing. It's that we need to construct an outcome that in some way accounts sensibly for the fact that some patients died. So it's a bit of a special case. Trevor's question.
So that's in this no bias slide that I put back up. Even though group differences are unaffected, is there still bias if the remaining sample has a higher or lower mean than the missing sample?
I think the point is that.
Oh, do you mean this slide? I'm not sure. Oh, this slide.
Yeah, there's two no bias slides, so we're not quite sure what you mean by that. How do you deal with missing this?
Yeah. In this slide, if the observed mean in the experimental group, if only the top pink distribution was shifted, then that will be a problem because we need there to be no intervention effect for this one to hold. And in this one, they're already different.